In this problem, we asked to find the variance and standard deviation for the data set. The standard deviation is a commonly used measure of spread, as it measures the spread of a data about its mean. Let's examine the formula for the standard deviation. It is given by S. Our standard deviation is equal to the square root of the sum of the deviations squared all over n minus 1. We might recall that a deviation given by x minus x bar can be found for each one of our data values. For example, we would now first calculate the mean, and the mean of our data set is going to be the sum of our data points divided by 9, which is given by 117 divided by 9, or 13. Therefore, our deviations are given by 1 minus 13, which is a negative 12, 2 minus 13, which is equal to a negative 11, 3 minus 13, which is equal to a negative 10, 5 minus 13, which is equal to a negative 8, 7 minus 13, which is equal to a negative 6, 9 minus 13, which is equal to a negative 4, 10 minus 13, which is equal to a negative 13, or negative 3, and finally 78 minus 13, which is equal to a positive 65. If I added up all these deviations, I would always get 0. Therefore, that is why in our formula we have the sum of the deviations squared. And instead of squaring all of our deviations, we can rewrite the formula for the standard deviation to be equal to the square root of the sum of our x values squared minus the sum of our x values all squared divided by n, and that whole quantity is divided by n minus 1. We can see that the sum of our x values squared is given by the following. We are going to take each of our 9 values and square them and add them together. If we do this, we get a total of 6,357. We want to know what the sum of our x values squared is. We know that the sum of our x's is equal to 117. Next, we want to take 117 and square it. When we do this, we get the following: 13,689. Therefore, the sum of our x's, all squared, divided by n, where n is equal to 9, is given by 13,689 divided by 9, which is 1,521. Now we're ready to put this entire information into our formula for our standard deviation. Our standard deviation is given by the square root of the sum of our x values squared, which is 6,357, minus the sum of our x values all squared divided by n, which we saw was 1,521. Finally, I'm going to divide this by n minus 1, or 9 minus 1, which is 8. This will give us a value for our standard deviation as the square root of 604.5, which is approximately 24.587. In order to find the variance, we will recognize that the variance is just our standard deviation squared, which is given by 604 1/2.